G'day everyone. Today we're going to take a look at the 2024 HSC Maths Advanced paper, specifically questions 23 to 31. Question 23 says a random variable is normally distributed with mean 0 and standard deviation 1, and then they provide us with a table of probabilities that relate to a z-score. The probability values given in the table for different values of z are represented by the shaded area in the following diagram. The scores in a university examination with a large number of candidates are normally distributed with a mean of 58 and standard deviation of 15. So that's, I think, the most important information from the question. So what we have is the mean equals 58 and then standard deviation is 15. By calculating a z-score, find the percentage of scores that are between 58 and 70. So what we should realize is that, well, 58 is the mean. And if we need a z-score between 58 and 70, well, we should just work out the z-score of 70 because we should know that the z-score of 58 is 0 as that is the mean. So we can say when x equals 70, so the z-score is equal to the score, 70, minus the mean, 58, divided by 15, which is the standard deviation. And that gives us 0.8. And then if we want to make it really clear, x is 58, z is equal to 58 minus 58 over 15, which is equal to 0. So therefore we have the probability that x is between, so x is the score on the exam. So the probability that x is between 58 and 70 is the same as saying that the z-score is between 0 and 0.8. And using the table of values above, it's essentially, well, what I can say is it's z is less than or equal to 0.8 minus the probability that z is less than or equal to 0. Yeah, less than or equal to 0. And the probability that it's less than or equal to 0.8 is this probability here. So is equal to 0.7881. And then the probability that z is less than or equal to 0, well, that's just 0.5. So our answer is 0.2881. But it asks us to find the percentage. And so that's just equal to 28.81%. Part B then says, explain why the percentage of scores between 46 and 70 is twice your answer to part A. So what I'm going to do is work out the z-score of 46. And that's going to be the similar process to what we did above. And what we end up getting is that it's equal to minus 0.8. And what we realize is that, well, the percentage of scores between 46 and 70 is the same as the probability that the z-score is between minus 0.8 and positive 0.8. So the reasoning is that by symmetry, the area will be twice part A. And then we can say, therefore, percentage is equal to 28.81 times 2. And that's equal to 57.62%. Part C says, by using the values in the table above, find an approximate minimum score a candidate would need to be placed in the top 10% of candidates. So this is just saying that we need to figure out a score that gives them a probability or like an area under the curve that is less than 10% essentially. So we need the probability under the curve. We need this area to be 10% or 0.1. And essentially we need to figure out what that z-score is going to be. So when we look at the table up above, what we see is that the z-score of 1.3 correlates to an area under the curve of 0.9, or 0.9032. And so this is the value where the leftover area is 10. And that's sort of what we want, because we want to be in the top 10%. So we want the rest of it to be equal to 90. And then we want it to be split with 10 there. That's sort of how we want this to work. So it's saying when Z is 1.3, this is this area here is 90.32% from that number up here. And then the remainder is, yeah, whatever it's going to be. So if we go back down to part C, what we will say is that, so the Z score is going to be 1.3, and we need to figure out the score itself, which is X. So we just sort of work backwards from the formula that we know. And then, yeah, we just sort of solve this, and what we end up getting is that X equals 77.5. And the minimum score would be, in this case, 78. Therefore, minimum. And the reason being is because if we take a number that's less than 77.5, then we're going to be less than this percentage of 90.32%. And it's likely that that will take us out of the top 10%, if that makes sense. So we sort of round up in this instance, and so the minimum score would be 78. Question 24 says, Jack intends to deposit $80 into a savings account on the first day of each month for 24 months. The interest rate during this time is 6% per annum, compounded monthly. Calculate how much money Jack will have in his account by the end of the 24 months. So important, so he's depositing $80, and it's on the first day of every month for 24 months. He's earning 6% per annum. So first thing, our rate is equal to 6% per annum. And then if we divide this by 12 to get a monthly rate, we get 0.5% per month. And that's really important because we're compounding monthly. So we want, everything to be in terms of months. Now, how much money will he have at the end of the 24 months? So essentially, we need to take this as 24 separate deposits and calculate the future value of all of those deposits. So I'm going to call a deposit D. And let's say deposit D1. Let me go back here. So let's say deposit D1 is equal to the $80 we invest multiplied by the 1.005, which is the 0.5% per month compounded rate, raised to the power of 24 because it's 24 months. D2, which is our payment on the second month, it's 80, 1.005 to the power of 23 because that's going in there for 23 months. Eventually we get to D24, which is the payment on the 24th month, and that's equal to 80 outside of 1.005 to the power of 1. Now the reason why it gets interest is because it's on the first day of the month, okay? That's why it accumulates interest for that whole month. If it was at the last day of each month, we wouldn't be accumulating this interest. So when we put it all together, the future value is equal to 80 outside of 1.005 to the power of 24 plus 80 outside of 1.005 to the power of 23 plus all the way to 80 outside of 1.005 to the power of 1. And if we take out a common factor here, we will get 80 outside of 1.005. And inside we have a, the remainder of what it is when we factor it out. Now I'm actually going to swap it around, as in I'm going to invert it. So these front terms I'm going to be writing at the beginning, and these ending terms I'm going to be writing at the, these starting terms over here I'm going to be writing at the end. That's what I meant to say. So when we factor out the 80 outside, when we factor 80 1.005 outside of 80 1.005, we get 1. And then the next factor is going to be 1.005, and then 1.005 squared, all the way to 1.005 to the power of 23. And then this here is just a geometric progression. So we can take the sum of that, which is going to be our ratio, which is 1.005 to the power of the number of terms, which is 24 minus 1, over the ratio 1.005 minus 1. And we can just plug this number in our calculator. And what we get is $2,044.73. That's to the nearest cents. Puppy says a table of future value interest factors could have been used to calculate how much money Jack would have in his account at the end of the 24 months. Part of the table is shown. What's the value of A in the table? Give your answer to 3 decimal places. So what we need to realize here is that how these future value tables work is that we take the deposit amount, we multiply it by the annuitive factor, which is going to be A in this case, and that gets us our future value. That's sort of how this formula works. So we can translate this and say that, well, the deposit was 80. We multiply that by A, which is the annuity factor we need to figure it out. And our future value is 2,044.73. And so that means A is just, we just divide both sides by 80. And what we get is 25.559. And that's the 3 decimal places. Question 25 says a function f of x is defined as follows. So essentially it's just a standard sort of probability density function that we would come to expect, and it's 1 minus x over h. So the question says find the value of h such that f of x is a probability density function. So f of x is a probability density function when the area under the curve is equal to 1. And the reason why is because if you sum up all the possible cases or instances of a probability, that sum should total to 1 because it should include 100% of the outcomes that could possibly happen. So for it to be a probability density function, we say 1. So I would say for it to be a P, D, F, I'd say 1 is equal to the integral from 0 to h of 1 minus x on h dx. So that means we can say 1 is equal to, when we integrate this, we get this. And when we substitute for h, we get h minus h squared on 2h. And that's equal to h minus h on 2. So 1 is equal to half h, and then h is equal to 2. And that's our answer. So that means, our PDF is going to be, now this isn't needed for the question or for the answer, but I'm just going to do it anyway. So 1 minus x on 2, and that's for 0, x, 2, and then 0 for x is greater than 2. So that's going to be our PDF there. Now part B says, by first finding a formula for the cumulative distribution function, sketch its graph. So it pretty much tells you what to do, but so we're going to find the cumulative distribution function, and to do that we need to integrate. And so we're going to say the integral of from 0 to just a value x, and then within the equation I'm going to replace the x for like a t, let's just say. It could be any other variable that we want, and then this is going to be dt. So this ends up being equal to t minus t squared on 4 from 0 to x, which is just equal to x minus x squared on 4. So therefore, we have our CDF, capital F of x, is equal to, we can say it's equal to 0. For x is less than 0, we'll say it's x minus x squared on 4, and that's for all values of x between 0 and 2, and then it's going to be 0 again for x is greater than 2. So that means to sketch its graph, well, we should know that at x equals 2, at the endpoint, I should say, because it's a cumulative function, the endpoint should have a y value of 2. Should have a y value of 1 because the gradient is going to be 1. And then for when x is equal to 0, its cumulative probability is going to be equal to 0, because that is essentially just when there are no outcomes, and so that's going to be our starting cumulative probability, and so that is just going to be 0. So to graph this, I've mistaken. So this is actually going to be 1. So when x is greater than 2, the probability is going to be 1. That's sort of just how the cumulative density function works. Because if you take any values greater than 2, it includes all of these values. And obviously the probability can't get any bigger than 1. The cumulative probability, that is, can't get any bigger than 1. So that's what it's going to be. So if I just mark 2 here, and then I say this is a 1. So anything after 2, the cumulative function is going to be at, the y value of 1. Now, what about before that? Well, before that, if we just look at the formula, we can see that it's a parabola. We know at x equals 0, the probability is also 0. So we're going to be starting here. And we should know that it's a concave down parabola. So it's going to sort of join like this, because essentially the part from 0 to 2 is part of a parabola that essentially looks like that, and we're sort of cutting it off there. So that's what this sort of shape is supposed to be, this like sort of curved shape. And yeah, that's our graph. 25C says find the value of the median of the probability density function. Give your answer correct to 3 decimal places. So now that we have the cumulative density function, the median occurs when that cumulative density is equal to 0.5, because the median is essentially the middle. So it's when the cumulative probability is equal to half. So what value splits the data in half so that there's an equal probability on both sides of each event occurring. So that's when x minus x squared on 4, which is our cumulative density function, is equal to 0.5 or is equal to half. I'm just going to expand this in order to solve it, and it seems like it's going to be, we're going to need the quadratic equation to solve this. So we get that, and then we get x squared minus 4x plus 2 is equal to 0. And then using the quadratic formula, we get x is equal to minus b, so minus 4, which is 4, plus minus root b squared, minus 4 squared, minus 4 times a, which is 1, times c, which is 2, all over 2a, which is 2 outside of 1. So we know it's 4 plus minus root 16 minus 8 on 2, which is 4, all on 2, which is 4 plus minus root 8 on 2. So that x equals 4. So root 8 is 2 root 2. Then we can divide all by 2. So there we go. We've got that. Now, what we should realize is that x needs to be less than 2. And the reason why it needs to be less than 2 is, it can't be greater than 2 because when it's greater than 2, that probability is equal to 1, but we're saying the probability is equal to 0.5. The reason why we get a solution is because what we're doing is we're solving an equation for like this parabola. So we have this parabola here, which might look like this, and let's say this is when y equals 0.5, and we get two solutions here. We get one there and one there. Essentially, we want to be taking the solution that is less than 2. So, therefore, that's going to be when x is equal to 2 minus root 2. And if we plug that in the calculator and work it out to 3 decimal places as the question asks, that's going to be a value of 0.586 to 3 decimal places. And that's question 25. Question 26 says, 25 years ago, Phoenix deposited a single sum of money into a new bank account, earning 2.4% interest per annum, compounding monthly. They give us a present value table for an annuity of $1 at various interest rates and periods. But this is the crux of the information. So Phoenix made the following withdrawals from this account. $2,000 at the end of each month for the first 15 years, starting at the end of the first month, and then $1,200 at the end of each month for the next 10 years, starting at the end of the 181st month after the account was opened. And we need to calculate the minimum sum that Phoenix could have deposited in order to make these withdrawals. Okay, so first things first, what we have is 2.4% and it's compounded monthly. The compounding frequency is the most important thing to pay attention. So 2.4% per annum is equal to 0.2% per month. And so that means we're going to be reading, and the reason being is because we divide by 12. So that means in this present value table, we're going to be honing in on this column here. Now, what we have here is 15 years and 10 years. So we should be converting them into the relevant periods, which is in months. So 15 years, if we multiply this by 12, it's 180 months. And 10 years is 120 months. Okay. So what I'm also going to do now is draw a bit of a timeline to describe what's happening. So let's say this is the timeline and this is at time 0. So for the first 15 years, or I should say for the first 180 months, what we have is a bunch of withdrawals that are worth $2,000. That's what's going on. Okay. Each of them, so this is sort of an annuity that's happening, and we need to be able to use the table to find the present value. And so the present value means the time value at t equals 0. So bringing it back to the beginning, and I'll explain why in a little while. So after 180 months, we've got 120 more months, which brings us to 300 total months, because I guess we span over 25 years, and so we take 180 plus the 120, and that gets us to 300. And then we have some more repayments, some more withdrawals, I should say, but these are these are $1,200. Now, the reason why we need to use the present value table is because we need to calculate the minimum sum that Phoenix could have deposited in order to make these withdrawals. So that just means we need to have a lump sum at time 0. So let's call it X dollars. We need to have X dollars, and X needs to be enough so that we can withdraw the $2,000 for 180 months, and then the $1,200 for the 120 months after that. So that's essentially what's going on here. So it's not too difficult of a question. I'm just going to scroll down a little bit. So what we can say is for the first 15 years, the present value is going to be, so 15 years equates to 180 months. So 180 months at a 0.2% interest rate gets us this factor of 151.036. So we take 151.036 and we multiply that by our withdrawal amount, which is 2,000. And that gets us with $302,072. Now this the present value of this 1,200 is a little bit more involved. It's not so simple. So what's going on is that, I'm gonna just highlight it in a few colors here, is we have this $1,200, okay? But if we calculated the annuity in the same way we did here, what we're gonna get is, well, actually, I'll just write it out. So for 25 years, if we look at the 25-year annuity, that equates to 300 months and 225.43. So that is 225.43 times $1,200. And that gets us $270,516. Now, what does that actually get us? This gets us this red section. So if we were to have the withdrawals of $1,200 for all 300 months, that's what this value gets us. What we need to do is we need to subtract it by this blue section here. So imagine we had withdrawals of $1,200 up until the 180th month. If we subtract the red and the blue section, we're going to be left with this, the green. Okay, that's essentially how it works. Hopefully you can see that red. Hopefully you can see that red minus blue equals green. So what I'm going to say is then, for 15 years at 1,200, we have present value is equal to, what do we have? We have 180 months again, so it's still going to use the 151.036 factor, but instead we're now multiplying it by 1,200, and that gets us with 181,243 and 20 cents. I'm just going to circle that in blue to indicate that's our blue section. And our answer, so the lump sum or minimum sum, therefore minimum sum is equal to $302,072, which is the $2,000 withdrawals for 15 years, plus 270,516 minus 181,243.20. Okay, which equals, what does it equal? It equals 391,344.15. And that's our answer. What I think a common mistake that people might make is they, for this sort of red and blue sort of reconciliation, is they might say, well, the difference between 180 and 300 is 120 months. So that means I'm going to be using this factor and I'll just multiply it by $1,200. That's wrong. The reason why that's wrong is because what this actually will calculate when you do that is it will calculate from 0 to 120 for the first 120 months. It'll calculate withdrawals of $1,200. But that's not what we want, because we want it in these 120 months. And so we need to consider the time value of money, because making withdrawals in the first 120 months, that's very different. We're going to need a different sum of money to withdrawals happening in this later end of 120 months. And that's because we have these first 180 months that are accumulating interests. So the fact that it's accumulating interest means that it gives us more time or more allowance in order to accumulate the sum that we want to. Anyway, so that's question 26. Hopefully that makes sense. Question 27, part A, says find the derivative of x squared tan x. So we're going to use the product rule, and we're going to be using VUV. So that is just where the derivative is equal to v u dash plus u v dash. So dy dx is equal to v, which is tan x, times u dash, which is the derivative of x squared, which is 2x, plus u, which is x squared, times the derivative of tan x, which is sec squared x. And that just gets us 2x tan x plus x squared sec squared x. So yeah, pretty simple. Now part B says, hence find the integral of x tan x plus 1 all squared dx. What we should know is that we should have experience with these types of questions, and we should know that we need to sort of rephrase this into what we see here in order to actually integrate it. So what I'm going to say is the integral of x tan x. So I can't really do anything with the equation as it is. So what I'm going to do is I'm going to expand it. So it's equal to x squared tan squared x plus x tan x plus 1 dx. Now tan squared x, we should know that 1 plus tan squared equals sec squared. So that means that's tan squared x equals sec squared x minus 1. So what we can say is it's equal to the integral of x squared outside of, sorry, this is 2x tan x, because it should be like, if this is a plus b all squared, it should be a squared plus 2ab plus b squared. And that's why it should be, the 2 should be there. Anyway, going back to this line, it's x squared outside of sec squared x minus 1 plus 2x tan x plus 1 dx, which is equal to the integral of x squared sec squared x minus x squared plus 2x tan x plus 1. And we should sort of have alarm bells ringing saying x squared x and 2x tan x. Well, that is very, very similar to what we have here. So let's sort of rephrase this into something that looks very familiar. So 2x tan x plus x squared sec squared x, and then we have minus x squared plus 1 dx. And now we can integrate it. So we have the integral of this, we have the integral of this, which, actually I'm just going to rewrite it, is the derivative, so 2x tan x plus x squared sec squared x. We've proven up here this is the derivative of x squared tan x. We know that. And then we have this minus x squared plus 1 dx. So if we were to integrate this, the integral of the derivative is just the function itself. So it's equal to x squared tan x. And then we should be able to integrate this pretty easily. So minus third x cubed plus x. And because it's an indefinite integral, plus c. And that's it. That's our answer. Question 28 says, Anna is sitting in a carriage of a Ferris wheel, which is revolving. The height A in meters above the ground of the top of her carriage is given by this formula here, where t is the time in seconds after Anna's carriage first reaches the bottom of its revolution, and c and k are constants. So what it's saying is that the carriage, when it's at the bottom here, that's, t equals 0, and then we go around in that sort of direction. Maybe I'll do this in red to make it more clear. So we go in that direction, and this is when t is equal to 0. The top of each carriage reaches a greatest height of 39 meters and a smallest height of 3 meters. So what that's saying is that this Ferris wheel sort of at its lowest point is 3 meters above the ground, but at its highest point is 39. That's essentially what it's saying. Part A then says, find the value of c and k. So c and k, what we should realize is that, well, this is just a cosine graph, and k will sort of act as the amplitude, and c will act as, I guess, the midpoint between the two endpoints. So what I mean by that is if you have a cos graph, which looks something like that, c is going to be this. So it's going to be that middle line. So if we imagine this is a cos graph, it's actually a negative cos graph. So I'm going to say, because it's a negative, it sort of looks like this instead. So we have that middle ground there, and this is equal to 3, and then the top is equal to 39. That's essentially what we have here. This is what this graph is supposed to sort of look like. And so this middle, this dotted line here, this is C. And we can see that it's supposed to be the middle. So C is equal to the midpoint of 39 and 3. So if we take the difference and divide it by 2, what we get is, this is just equal to 21. And then K is the distance. So this is 21. K is essentially the amplitude. So it's the distance between 21 and 3 and 21 and 39. So we can just say it's 39 minus 21, which is equal to 18. And that's it. That's our constants. Part B then says, how many seconds does it take for one complete revolution of the Ferris wheel? So for one complete revolution, it needs to go all the way around and return to the beginning. Okay, it needs to return to that bottom there. What we need to realize is that, well, yeah, this is a cosine graph, and we should know something about returning to its starting point, like a periodic pattern that the cosine and the sine graphs take, and that is the period. So the period is 2 pi on b, which is 2 pi on 24. And that is essentially the time it takes for a complete revolution. And if we just put this in a calculator, we get that it's equal to 48 seconds. So a very, very simple calculation there. Question 28 says, Billy is in another carriage. The height BT in meters above the ground of the top of her carriage is given by this new formula here, where C and K are the constants that are found in part A. Question then says, during each revolution, there are 2 occasions when Anna and Billy's carriages are at the same heights. At what 2 heights does this occur? Give your answer correct to do the 2 decimal places. So they're the same height, which means, sorry, when Anna and Billy are the same height, that's just going to be when their equations are equal to each other. So it's going to be when C minus K cos pi on 24t, when that's equal to C minus K cos pi on 24t minus 6. So when those are equal. Now, one thing we need to keep in mind is that it's when they're the same height on two occasions each revolution. So two occasions means that we're going to have two solutions. So that's something that we just need to be very mindful of. Now to solve this, essentially we can just subtract the C's and then divide the negative K's. I hope that's intuitive to see. So what we'll be left with is this. Now, how do we solve this? Well, we can remove the cos on each, and we can say pi on 24t is equal to pi on 24t minus 6. But this has no solutions. And the reason why it has no solutions is, well, you can't solve for t here, because what you'll get is 0 equals minus 6 pi on 24. That's essentially what you get. And obviously 0 does not equal negative 6 pi on 24. So there's no solutions for t which satisfy that equation. So how do we get a solution? Well, what we need to realize is that cos x, if we just have cos x, that's equal to cos of minus x. That's something that we should know, because cos, as we should know, is an even function. So f of x is equal to f of negative x. So that defines an even function. And you can plug plug values of x in your calculator, and you can see that it's true. But on top of that, cos x is also equal to, using our knowledge from ASTC, it's equal to 2 pi minus x. So, yeah, that's, something to keep in mind there. And so instead of x, imagine I have pi on 24t. So that means I have two more equations. I have instead of pi on 24t, which would be x, I'm going to do minus x, which would be minus pi on 24t. And that's equal to pi on 24t minus 6. If I solve this, what we'll end up getting is minus pi on 24t equals pi on 24 minus 6 pi on 24. And then what we'll end up getting is that pi on 12t is equal to pi on 4. And we'll get that t is equal to 3. Therefore, so we have this line here. So when x is equal to pi on 24t, we can say that this is the same as 2 pi minus x, or 2 pi minus pi on 24t. And that's going to be equal to pi on 24 outside of t minus 6, which is equal to, so 2 pi minus pi on 24t is equal to and then what we have is pi on 12t is equal to 2 pi plus pi on 4. And and then we will have and if we solve this, we just get t is equal to 27. We know that, remember, the revolution is 48 seconds. And so our two solutions need to be less than 48 seconds for that reason, because they need to occur within the whole revolution. So we've got these two these two solutions. So what's our answer? Well, remember the answer is at what two heights does this occur? So that means we just need to plug in our answers. So we will say when t equals 3, h is equal to 21 minus 18 cos outside of pi on 24 times 3. So that's just plugging it into this equation here. We can solve that and we just get 4.37. Now it's in meters. And then we say when t is equal to 27 and we plug it in again. And that will get us 37.63 meters. And that's it. That's our answer. Question 29 says, consider the curve y equals ax squared plus bx plus c, where a doesn't equal to 0. At a particular point, the tangent and normal to the curve are given by the tangent line, 2x plus 3, and the normal line, minus half x, minus 2, respectively. Curve has a minimum turning point at x equals minus 4. Find the values of a, b, and c. So let's start with the minimum turning point being at x equals minus 4, because I feel like that gives us the most information. So we've got y equals ax squared plus bx plus c. So that means dy dx is equal to 2ax plus b. Now we know it's a minimum at x equals minus 4, so therefore at x equals minus 4, dy dx equals 0 because it's a minimum, so that means the gradient is equal to 0. So 0 is equal to 2a times minus 4 plus b. So we get 0 equals minus 8a plus b. So b is equal to 8a. That's great. That's good to know. Now, what we need to figure out is, well, when the tangent and the normal meet, that's going to be when, that's going to be a point on our curve. But we can also just figure out the point in which they meet in general, which will give us a lot more information. So we'll say when t of x equals n of x, which is essentially just when the tangent and normal meet, 2x plus 3 equals minus half x minus 2. And we can solve for x. We can say, what can we say? We can say 5x on 2 is equal to minus 5. And that means x is equal to minus 2. And then at x is equal to minus 2, we have y is equal to 2 plus 3. And that's just plugging it into the tangent formula. I could have plugged it into the normal equation, but you'll get the same answer. And that is equal to, this is minus 2. That's equal to minus 4 plus 3, which is equal to minus 1. Therefore, minus 2 minus 1 is a point on the line. Now we know this is a point on the line, and on top of that, we know what the gradient is going to be. And that is 2. And that's because the gradient of the tangent line is equal to 2. So what we can do is we can sub it into our gradient formula, and we can say, therefore, 2 is equal to 2a outside of minus 2 plus b. And I hope that sort of makes sense. And we can say 2 is equal to minus 4a plus b. Now we know b is equal to 8a. Therefore, 2 is equal to minus 4a plus 8a. 2 is equal to 4a. A is equal to 1/2. And now we knew, therefore, b is equal to 8 times half, because b is equal to 8a. And so b is equal to 4. So now how do we solve for c? Well, we need to come back to the starting equation. We know a, we know b, and we have a point on the line which is 2 minus 1. So that means we know y and x. So therefore, so when x equals minus 2, y equals minus 1, so we have minus 1 is equal to a, which is half, outside of x squared, which is minus 2 squared, plus b, which is plus 4, outside of x, which is minus 2, plus c, which is what we want to figure out. So we end up getting minus 1 equals 2 minus 8 plus c. Minus 1 equals minus 6 plus c. And then c is equal to 5. That's our answer. And that's the question complete. Question 30 says, suppose the geometric series x plus x squared plus x cubed and so on has a limiting sum s. By considering the graph of y equals minus 1 minus 1 on x minus 1, otherwise, find the range of possible values of s. So the limiting sum is equal to a on 1 minus r. And so a is x and our r is x. So our limiting sum is equal to x over 1 minus x. Now this graph, what we should know is it's a hyperbola. And what does a hyperbola look like? Well, if we have the basic hyperbola 1 over x, we should know that looks like that. Okay? Now this has a x minus 1 here, which just means that the graph is shifted to the right by 1. So that's now 1 over x minus 1. Then what we have is a minus in front of all of this. So if I was to graph minus 1 on x minus 1, we essentially just flip it. And so now we have this. And then the final thing is that we have this, I guess, y component of minus 1. And what this is essentially just a y translation. And so what it is doing is it's translating it down by 1. Okay, so we have another asymptote. So before we had the asymptote at 0. So this sort of just now moves to negative 1 because it moves down by 1. So I'm going to label actually my asymptotes. So this is just 1 and then this is minus 1. I should be more clear. So this should be 1 and this is minus 1. And what our graphs look like is, oops. Our graphs look something like that. Okay, not our graphs, our graph, I should say. So that's what it looks like there. But how does this actually relate to the question? Well, what I'm going to do is I'm going to say the graph, well, this has a formula y equals minus 1 minus 1 over x minus 1. Now this might be a little bit difficult to figure out and see, but you sort of have no choice but to realize that this equation should look something like that because we need to figure out the limiting sum and it's telling us to use the graph to do so. So what we're going to do is we're just going to, combine it all into one fraction because we know we need it to look like this. So that's going to equal to minus x minus 1 all over x minus 1, which is equal to minus x plus 1 minus 1 over x minus 1, which is equal to minus x over x minus 1. Now that's not, it doesn't look like that, but we can get it to look like that if we take out a negative from the bottom. So what we can get is it's minus x outside of minus 1 minus x. Okay, that's essentially what we can get there. And then these negatives cancel, and so we get it's equal to x over 1 minus x. So what we're saying is that, well, the limiting sum, like this equation here, is actually this graph here. And when does the limiting sum occur? Limiting sum occurs when x is between 1 and minus 1. So the range of possible values of x are essentially our y values between 1 and negative 1. So I'm going to do that in blue. So between 1 and negative 1, whatever the y values are, that's going to be our possible values for s. So what we need to realize is that it's essentially this part of the graph, and we need to figure out what this minimum is going to be, and that's going to be when x equals negative 1. So I'm going to say at x equals negative 1, y is equal to minus 1 on 1 minus 1, which is equal to minus a half. And so what that then means is that therefore, oh my god, sorry. What it means is that therefore s is greater than minus a half. And the reason being is because we know that the domain, because it needs to be a limiting sum, the ratio r needs to be less than 1 and minus 1. And that, using this graph, we've concluded that that happens when it's greater than 1/2. And so that's why our answer is this. Question 31, the last question of the paper, says two circles have the same center O. The smaller circle has radius 1 centimeter, while the larger circle has radius 1 plus x centimeters. The circles enclose a region QRST, which is subtended by an angle theta at O, as shaded. So QRST is this. The area QRST is a centimeters squared, a is a constant, and a is greater than 0. Let p centimeters be the perimeter of QRST. By finding expressions for the area and perimeter of QRST, show that the perimeter is equal to 2x plus 2a over x. So perimeter, how do we work that out? Well, we know perimeter is QT plus RS, which are both equal to x, plus QR, which is the arc length of the larger circle, plus TX, which is the arc length of the smaller circle. Arc length, we should know, L equals R theta. So that means QR is equal to 1 plus x theta, or it's equal to theta plus x theta. And then TS is equal to 1 times theta, which is just equal to theta. So that means perimeter is equal to x plus theta plus x theta, and that's QR right there, plus theta, which is, that's TS. When we add all this together, we get 2x plus 2 theta plus x theta. Now what I'm going to do here is, we know that we need to figure out that our perimeter is equal to 2x plus 2a on x. So we need to somehow substitute an area formula into this equation. But notice there's a 2x here and we already have 2x. So let's keep this and let's, I guess, put this in a, let's factorize this. So we can factorize theta. So theta outside of 2 plus x. Okay. Now, how do we deal with the area? Well, we should know that the area is equal to, the area is going to be equal to the area of a section. Yeah, the area of a of a section of a circle is half r squared theta. And what we're going to have is, we're going to have, to figure out the area of QRST, we're going to need to figure out the area of the section of the larger circle, which is in red that right there, and we need to subtract it by the area in blue, which is the section of the smaller circle. So I'm just going to rub this out. So half r squared theta, remember that. So it's going to be half r squared, which is r squared of the bigger circle, 1 plus x, that's the radius, squared, theta, minus half r, radius 1 of the small circle, squared, theta. And that's equal to half 1 plus 2x plus x squared theta minus half theta, which is equal to half theta plus 2 plus x theta plus half x squared theta minus half theta. Collect like terms, so we get a is equal to x theta plus half x squared theta. Now we know we need to substitute a into the perimeter formula, and we know it needs to be in this section here, because remember the 2x is sort of locked in there. So how can we write this to be in some sort of form where we have 2 plus x factored out? Well, sorry, we have theta factored out. So let's, oops, let me change it to black. So what we can say is this is equal to theta x outside of 1 plus half x. Yep. Now, we need a 2 plus x, remember? That's sort of what we need here. So what we can say is we can factor out a 2, theta x, and that gets us, if we factor out a 2, we get, if we factor out a half theta x, so that means we get 2 plus x, and this is now looking more like what we want. And so if we have the 2 plus x now, and we want to keep the theta as well, because we want to find an equation for theta outside of 2 plus x, so we multiply the half over, so we get 2a is equal to theta x 2 plus x, and then we divide the x over, and there you go, that's what we, that's what we get. So then we can say, therefore, p of x is equal to the 2x plus, now instead of theta outside of 2 plus x, we can say it's equal to 2a on x. And there you go. That is, that's us showing that equation exists. Question 31b says, show that if the perimeter p of x is minimized, then theta must be less than 2. So I'm just going to rewrite the equation, and I'm going to say p of x is equal to 2x plus, now I'm going to say it's equal to 2a x to the minus 1. Reason being is because we know we need to derive this to get our minimum. So px is equal to 2 minus 2a x to the minus 2, which we can just rewrite as this. Stationary points occur at p dash of x is equal to 0. Therefore, 0 is equal to 2 minus 2a on x squared. 2a on x squared is equal to 2. 2a is equal to 2x squared. X squared is equal to a. And that means x is equal to plus or minus root a. But we know x is greater than 0. Therefore, x is equal to root a. Now, why do we know x is greater than 0? Remember, x is a length. And lengths can't be negative. And that's why we consider it to be greater than 0. So x is positive root a. Now, for it to be a minimum, let's look at the second derivative and test, its concavity. So this is going to be, this is equal to 4a x to the minus 3, which is 4a on x cubed. And then at x equals root a, we have p double dash of root a. P double dash of root a is equal to 4a on a root a cubed. And, well, we know that, which is greater than 0. We can just say it's greater than 0, and the reason why is because a is greater than 0. So a is greater than 0, so all these different values are greater than 0. So we can say it's positive. So that means it's therefore a minimum at x is equal to root a. So great. So we know that. Now what we need to find is the value of theta, which minimizes this. And we know that this is the formula for the area. So I'm just going to rewrite it. So a equals x theta plus half x squared theta. And so at x equals root a, we just plug it into this equation here. So we say that a is equal to root a times theta plus half root a squared theta. So that means a is equal to root a times theta plus half a theta. I'm going to factor out the theta because essentially that's what we want to solve, because we need to show that it's less than 2. So I'm going to factor out this. So we get root a plus half a. And then if I divide it by the 2, I get theta equals a over root a plus half a. Now, how do I prove that this is less than 2? Now, this can be a little bit tricky, but essentially, I don't like this half. I want like more 2's. So let me sort of expand this and say it's equal to 2 root a plus a all over 2, which is the same as saying it's equal to 2a on 2 root a plus a. Now, if I factor out a root a from the bottom, I get 2a on root a outside of 2 plus root a. And then root a goes into a. And so on the top, we're left with 2 root a, because root a goes into a root a times, over 2 plus root a. And essentially, well, this is less than 2 root a on root a. How did I get that? Like how am I able to say that? Well, what's the difference between this and this? And the difference between both of them is that the 2 on the denominator is nowhere to be seen. If you think about it, if we have an equation like if we have an equation like 3 over 4, I could break this down. Let me say it's something like 3 and 8. I can break the 8 down and say it's 3 over 2 plus 6. Okay? Now, if I wipe out the 2, I'm left with 3 over 6, or it's a half. And we should know that a half is bigger than 3 over 8. So what we can see is that when the denominator, right, is a smaller number, we have a bigger overall number. Like the fraction itself becomes larger when the numerator is smaller. So when we take 2 out, we're effectively making the numerator smaller. And so that means the resulting number is larger, right? And so we can just take out the root a's, and what we're left with is we've concluded that theta is less than 2. And that is our answer done.